So guys, I hope you have just completed a small revision of what all we saw. Again, I am telling you the nature of Indian monsoon will remain same. We need not bother much about this particular issue, right? So let's go in detail and start analyzing how exactly Indian monsoon has been explained in 11th standard NCERT book and what are the additional points that they try to see. I will be repeating these points again so that it will be quick revision for you, and at the same time it will also help you to understand the concepts or basic concepts which you would have already seen. So as I have told you, whenever we read NCERT books, it will help us to revise the concepts twice. So along with you, I am also revising these concepts twice. So even if you have not understood in the first time, it will be beneficial for you to understand now, right? So please don't think it's more repetitive, but we are trying to ensure that some of the concepts are so important for our exam that if it appears multiple times, you can understand that more questions can come from this particular area. So let's quickly begin with the nature of Indian monsoon. Different geographers at different point of time has actually tried to explain what exactly is Indian monsoons and how it is occurring. Initially, it was just a local phenomena associated with ITCZ shifting northward. And they said that in winters, ITCZ was in the southern hemisphere, so northern hemisphere saw winter. India actually was under extreme cold conditions, that means high pressure area, and this led to winds blowing from land to sea. Whereas whenever ITCZ shifted northward, that is over 23.5 degree north, then we usually observe that high temperature is noticed there. High temperature leads to low pressure, and this led the high pressure in the Indian Ocean to move towards India. And whenever the high pressure in the Indian Ocean started moving towards India, first they have to come closer till equator. And after crossing equator, the southeast trade winds will turn to southwest trade winds and they enter into India, right? This is what we have seen till now. But now we have to see when exactly does this enter. We have Bay of Bengal and we have Arabian Sea. So we have to see which one will come first, which one will have huge impact. So all this basic information, addition to whatever you have seen in the 9th standard NCERT book, has to be seen now. So first, to begin with, I have to look into the nature of Indian monsoon. So whenever I am looking at the nature of Indian monsoon, I have to tell you that there are certain features which are very important. That is onset of the monsoon. As I told you, which one will start first is very important. Second important thing, the rain bearing systems, that is tropical cyclones, usually come wherever warm water accumulates, and these tropical cyclones are being brought over India through the easterly jet streams, and these easterly jet streams give heavy rainfall. Recently we have seen a phenomena where there is reversal of this, or we can say that the cyclones, rather than coming over India, they went ahead. And due to recurving of this cyclone, India, especially east coast of India, did not receive much rainfall. So let us see that part as well. And then as usual they have spoken about the breaks in the monsoon, but here they say how exactly the breaks in the monsoon is taking place in North India and also in the Western Ghats. So all this needs to be seen in detail. So whenever we talk about the onset of the monsoon, they try to explain the differential heating that is usually observed in land and oversea with respect to the movement of the sun. So initially the most important aspect that you will observe is that towards the end of the 19th century, differential heating of land and sea during summer months is the mechanism for monsoons. During April and May, when the sun shines vertically over Tropic of Cancer, the large landmass in the north of Indian Ocean gets intensely heated. What will happen? This will actually lead to low pressure in the northwestern part of the subcontinent and high pressure exists in the Indian Ocean. So, right, once the water is in high pressure and the air moves towards low pressure cells, and once it crosses equator, this becomes southwest monsoons. And this southwest monsoon is nothing more than southeast trade winds deflected towards the subcontinent after crossing equator. Where exactly does this deflect? It is in between 40° east to 60° east longitudes. Is this important? Yes, it's very, very important. Let's understand with the help of map. Here, I am just trying to tell you that in this particular portion, we have high pressure area. And here extreme low pressure is being seen. Winds usually blow towards left in the southern hemisphere, correct? And then from here they start blowing like this. Can you see? So this is 40 to 60°, right? So this is 40 to 60. So 40 to 60 usually comes here. So once the wind starts deflecting in this region, high possibility that they actually enter towards India and they also enter into Southeast Asia. Else we will see another phenomena where if the wind starts deflecting somewhere here, they may enter into Pacific Ocean rather than giving rainfall to our region. So the deflection at a particular point is very, very important. Or let me take the deflection is actually happening here, and then if it moves here, it gives to Pakistan, Iran and other things, but it doesn't give enough rainfall to this region. So what is more important? 40° east to 60° east is also very, very important, right? And then we need to understand that the shift in the position of ITCZ is also related to the phenomena of the withdrawal of westerly jet stream. I have already told you that when you have Himalayas, the jet stream first comes and hits, one portion will go down, one portion will come below Himalayas. With the northward shifting of ITCZ, we also observe that this westerly jet stream will actually move beyond and this will not be present. And after this what we observe? There will be easterly jet stream observed. And this easterly jet stream is coming mainly because of the northward shifting of the ITCZ. Wherever winds converge and whenever they raise, and you know that at the tropopause they diverge. So let me just explain you this. If I am actually talking about the land surface, you know that the winds start raising, and as the winds start raising, it hits tropopause. When it hits tropopause, it diverges in opposite direction, correct? But can you see there will be some air getting accumulated at this point, and this will be there throughout the equator. Convergence or divergence at this point usually leads to some air being present. Similar to if you have water, pour water in a room, the water which goes and hits the wall, after hitting the wall they turn in opposite directions, but some water will be there along the wall. That is what we say, usually some sort of jet streams will be there. This jet stream is more or less absent in equator, but once this moves above or below, usually we observe an easterly jet stream appearing, right? So let's look at the image. So here, can you observe this particular one? Tropical easterly jet stream. What is happening? The southern Hadley cell has shifted northward. So because of this, can you observe some sort of jet stream being developed here? This is what we call tropical easterly jet stream. Don't try to remember why it is formed. What you need to see is, with northward shift of ITCZ, we usually observe that the westerly jet stream which is there will also shift northward. And near ITCZ, we also observe some sort of easterly jet stream originating. And this easterly jet stream will never move beyond 23.5. Why? Because it is closer to the low pressure cell which is created due to ITCZ. Right? This is what we need to observe. Yes, then we need to see that the easterly jet stream sets in along 15° latitude only after the western jet stream has completely withdrawn. This easterly jet stream is responsible for burst of the monsoon in India. What is the meaning of this? What I mean to say is, when the easterly jet stream comes, two things are happening. Westerly jet stream is actually moving above, and at the same time the easterly is coming. So the easterly will bring moisture laden winds to India, and this gives heavy rainfall. And heavy rainfall is actually called as burst of monsoons, right? This is very, very important for us. Then we need to talk about the entry of monsoon into India, where we need to see that the southwest monsoon sets in over Kerala coast by 1st June and moves swiftly to reach Mumbai and Kolkata between 10th and 13th. By mid-July, southwest monsoon engulfs the entire subcontinent. But here you need to understand a simple fact that, can you observe here 1st June is there? Bangladesh. Can you observe here 1st June is there? Can you observe Indian coast receive rainfall, that is Kerala coast also receives rainfall, and also can you observe the Bangladesh also receives rainfall, and can you see Bay of Bengal branch is receiving or giving rainfall almost at 23.5°, whereas the Arabian Sea is giving at 8° north. The meaning of this is Bay of Bengal branch moves first and then the Arabian Sea branch comes. But when we actually look at the arrival of monsoons on Indian land, we say 1st June on Kerala and 1st June is there on Bangladesh. So usually we consider at Kolkata it came much later. Almost 10th June is the time when the monsoon reaches Kolkata. And can you see the northeastern India receives rainfall by 1st June in between 1st to 5th June. So here what you have to understand is, first you have to see that in the peninsular India, when we are actually considering, the rainfall is increasing from south to north, whether it is Thiruvananthapuram, Bangalore, Hyderabad, Mumbai. So if I have to arrange the cities, first Thiruvananthapuram, then Bangalore, then Hyderabad, then Mumbai. And if I have to arrange the places in the North India, then I have to say first Kolkata, then Patna, then Lucknow, then Chandigarh. So it has to go in this particular fashion, right? So according to NCERT books, our explanation varies normally, but according to NCERT books, we say or we arrange the cities from south to north in the peninsula and east to west in the North India. That is, Arabian Sea branch usually moves from south to north, Bay of Bengal branch moves from east to west. And then we need to look at the rain bearing systems and rainfall distribution. Here you all have to understand that there are two rain bearing systems of India which originate first in the Bay of Bengal. I have already explained you this in detail. Second is the Arabian Sea current of the southwest monsoon which brings rain to the west coast of India. Much of the rainfall along the western Ghats is orographic, that is because of mountains being present. I have already told you that whenever you have mountains, the clouds start raising and the raising clouds will condense and give heavy rainfall. But once it comes down, it gets heated up and doesn't give much rainfall. So this is what we say orographic rainfall, and this usually depends upon two major factors, that is offshore meteorological conditions that usually exist in the ocean. That is, if you actually consider India, the meteorological conditions which are there is very less. But the offshore meteorological conditions, that is the Indian Ocean dipole, El Nino, La Nina, all this tries to explain how exactly the winds are going to blow towards India. Then we need to understand the position of the equatorial jet stream along the eastern coast of Africa. I have already told you that whenever we talk about the winds blowing after crossing equator, it should be in between 40 to 60. So this position is also very, very important. Whenever the position changes, I have already told you there will be impact. So this is what we are trying to say. The position of the equatorial jet stream along the eastern coast of Africa is also very, very important. Let me explain this with the help of a diagram. So can you just observe here? You have high pressure, you have low pressure. So this is actually moving in this direction. It is rising and it is coming back. And this is called as tropical easterly jet stream, which is originating near this. This position is also very, very important. If this varies, and this varies mainly because of El Nino effect, at that point of time, we usually observe that there will be less rainfall. That is, remember guys, if this is extremely high and this is extremely low, for example, here it is 1000 and here it is 600, then the winds will blow in this direction, correct? But if this becomes 900, the difference is less. Because of this, usually the wind movement is reduced in this region. So this is what we need to understand. That is, with changing temperature, with changing circumstances, usually the high pressure and low pressure keeps on changing. Whenever high pressure and low pressure difference is more, the intensity with which the winds blow will usually be more. Whenever the difference is less, then the intensity is usually less. Let me just give you a small example. If I take this particular thing, if you look at the slope, can you see the slope is low? So the wind movement will be slow, correct? Or water movement will be low. But whenever I turn this like this, the meaning of this is, can I say the flow of the water will be more, speeder? What is the reason for this? Here we try to say that if we have it in this, the difference between high pressure and low pressure is usually less. And whenever we say this, difference between high pressure and low pressure is usually more. This we need to talk. Is that fine? It is very, very important for us to look at this particular issue. That is, if the difference between high pressure and low pressure is more, there is a possibility that winds blow from Mascarene high to Tibetan low easily, else it will be less. So when does this reduce? Usually during El Nino, what happens? You will have 600 here, it doesn't change. But what changes is the 1000 that is there in the high pressure. Usually whenever El Nino occurs, we observe that the high pressure near Mascarene high varies. Due to changes in this, the difference between the high pressure and low pressure reduces, and this will have huge impact on the monsoons. So let us understand how exactly El Nino will try to have impact. So if you actually look at this particular diagram, can you see that the winds are blowing like this? So because of this, warm water is getting accumulated here. Can you see the surface water is coming? And the cold water is coming up. So can I say here I have cold, here I have warm. The meaning of this is high pressure is here and low pressure is here. Sometimes you actually see the westerly winds blowing, which bring warm water here. The trade winds will come and it will also bring warm water here. So due to this, rather than warm water being present near Australia, it will be present at the center of the Pacific Ocean, or sometimes this may be present at the corner. We have two types, El Nino Mudaki and normal El Nino. So normal El Nino occurs, warm water accumulates here, El Nino Mudaki occurs here at the center. So if it is present here, then usually what you see, low pressure will accumulate here and high pressure will be seen here. And whenever you have low pressure here and high pressure here, winds start blowing in this direction, correct? So let me just explain you the picture. That is, if I take Africa, if I take Australia, and if I take South America, right? So I am actually trying to tell you that in the normal year, cold is present here, that is high pressure is present. Low pressure exists here, that is warm water exists here. And due to winter, in this particular region, high pressure will be there. Winds blow from high pressure to low pressure, high pressure to low pressure. Usually we observe that warm water after crossing equator will also be present here, but let us understand this. Now it is rising here and it comes down. It comes down, right? But whenever El Nino takes place, warm accumulates here, that is low pressure will be here, high pressure will be here, and high pressure will be here, right? This also doesn't change. Can you see winds blowing in this direction? This may be 1000, this may be 800, this may be 600. So it's moving in this direction. Once it moves in this direction, the wind distribution will be affected. Normally what happens, from high pressure of Africa, only less amount of air moves like this, but more intensity will be towards India. But because of this pressure increasing, more winds start blowing like this and less winds or weakened winds will blow like this. Whenever the weakened winds will blow like this, they carry less moisture. And if they carry less moisture, less rainfall is usually seen on the India, right? So this is what we try to see here. Can you observe this? El Nino and the Indian monsoon. What happens? There will be distortion of the equatorial atmospheric circulation. Did I showed you the two important circles? That is, the circulation will be affected. Walker's circulation will be affected. Irregularities in the evaporation of the seawater, I showed you first it was near Australia, but during El Nino year it will be near Peru. This will actually create trouble. And whenever water doesn't come from below, they do not bring amount of planktons. That is, I showed you that the cold water rises. Whenever cold water doesn't rise, they doesn't bring enough food. And if there is no food, number of fishes reduces. This usually occurs during Christmas. We call it Child Christ or El Nino, right? Very, very important for us. Then we also need to understand that the frequency of tropical depressions originating from the Bay of Bengal varies from year to year. I have already told you clearly that tropical cyclones originate mainly because of accumulation of warm water. Wherever warm water accumulates, and if it is more than 23 degrees Celsius, high possibility that there you can actually see some sort of cyclones developing. And these cyclones are brought towards India through the easterly jet stream which is present over Bay of Bengal and India during monsoons. So whenever you have this, then you will usually observe, with more number of tropical cyclones being formed, we usually observe that more rainfall is usually seen. This is what we say with respect to frequency of tropical cyclones determine rainfall on India as well. Their paths over India are mainly determined by the position of ITCZ, which is generally termed as monsoon trough, correct? As the axis of the monsoon trough oscillates, that is, if it moves above and below, there are fluctuations in the track and direction of these depressions, and the intensity and the amount of rainfall vary from year to year. The rain which comes in spells display a declining trend from west to east over the west coast and from southeast towards northwest over North Indian peninsula. Here two things they are trying to say. First important thing is this, that is ITCZ. So let me just show you with respect to this. See guys, ITCZ is usually present here, 23.5, but because of high temperature being noticed in the northwestern part and also Tibet, correct, we usually see intense low pressure at various points. So with ITCZ shifting sometimes here, sometimes here, usually we observe that the rain bearing tropical cyclones also move. Sometimes whenever the ITCZ shifts extremely north or if it moves south, usually we observe different winds cover this particular region. Recently a cyclone which was actually coming towards India, they rather than hitting the coast, they turned like this because of the fluctuations that is observed with the ITCZ. Whenever these fluctuations happen, that is whenever the weakening of this takes place, then we usually observe the curvature, recurvature, rather than entering into Indian coast giving rainfall and recurving, before entering itself it recurved. And because of this, the eastern coast of India did not get much rainfall. Again now because of cyclones you are getting rainfall, but still it didn't get rainfall because of this. That is, see guys, you might have heard floods in Patna, you might have heard floods in Gujarat. That is mainly because the low pressure is being developed here or low pressure is developed here. So because of this, from Arabian Sea winds blow, moisture laden winds blow. Just imagine you have the low pressure area, correct? And whenever moisture laden winds come over low pressure area, high possibility the winds start raising. Whenever the winds start raising, they give heavy rainfall. This you are aware. So if this is present over Gujarat, Gujarat will get heavy rainfall. If this is present over Bihar, winds will blow from Bay of Bengal, they rise and give heavy rainfall. So floods happen in Gujarat, Rajasthan, Bihar because of the low pressure present there. Sometimes if this low pressure rather than being present near Bihar, if it shifts to northeast India, right? So the winds rather than blowing like this, they start recurving and they start blowing like this, and then this leads to recurvature and enough rainfall will be seen in northeast India but not in the east coast. So what I am trying to say is ITCZ usually shifts north and south on the basis of the intensity of heat received at different points of time. Due to climate change and other phenomena, not only Tibet, other parts of India also receives excess heat. Whenever it receives excess heat, high temperature is usually seen. High temperature leads to low pressure. Wherever low pressure is established and whenever winds blow, the winds blow over the low pressure area and starts raising. Whenever it starts raising, usually it gives heavy rainfall. This gave rainfall to Gujarat, this gave rainfall to Bihar. But the ITCZ was not static, it was moving throughout. Whenever it moved extremely, then we usually observe the cyclones or tropical depressions which were formed in Bay of Bengal also started recurving and it did not give rainfall to the east coast of India. This is what we try to understand. Is that fine? So no need to worry much. Once in a while UPSC will ask you questions with respect to this. So you should understand the logic. I am just trying to tell you how every line usually try to explain even the phenomena which is going to come. But when you try to read, every line needs detailed explanation, and if you don't have the background information of that, it would be very difficult for you, right? The second important point which they say is the rain which comes in spells displays a declining trend from west to east over the west coast and from southeast towards northwest over North Indian plain. So what is the meaning of this? The meaning of this is when we talk about the Western Ghats and all being present, rainfall will be more on the western side, and as you move it decreases. So west to east rainfall decreases, And when I am talking about the plains, southeast in this region, northeast and southeast, more rainfall, correct? Here, northwest, less rainfall. So, rainfall reduces from east to west in the plains and it reduces from west to east in the peninsula. So, peninsula is west to east because mountains are there, and Bay of Bengal branch first hits the eastern Himalayas and then move that side. So, we say it is moving or it is reducing from east to west. Please try to remember this carefully. High possibility UPSC asks you questions from this, right? And then we observe breaks in the monsoon. Breaks in monsoon means there is dry spell within monsoon. So, let us see why exactly this is usually occurring. So, whenever we say dry spells, in North India, the dry spell is mainly because ITCZ will keep on moving, are likely to fail if rain-bearing storms are not very frequent along the monsoon trough or the ITCZ over this region. So, let me just explain you. I have ITCZ in this region. ITCZ is low pressure area, correct? So, if winds are blowing like this, or if winds are blowing like this, let me take. If winds are blowing, by the time these winds, if they reach ITCZ, if it gets exhausted, that is moisture content is not there here at all. Because of Western Ghats being present, Arabian Sea branch will give more rainfall in the Western Ghats. By the time they enter into ITCZ here, then rainfall is less. But here when you take the Bay of Bengal branch, which hits this region, and again when it is coming back, by the time it comes back, the amount of moisture present here may also be less. Then can I say again rainfall reduces? So what they are trying to say here is, that is, over ITCZ, if rain-bearing storms or clouds are not coming up, then they won't give rainfall. This is what the first thing they try to say. Second important thing, over the west coast, the dry spells are associated with the days when winds blow parallel to the coast. When we actually take the Western Ghats, winds are blowing like this. Whenever winds blow like this, they rise above the mountains and give rainfall on the western side. Eastern side will receive less rainfall, this we know. But when it is taking place, some winds will start blowing like this. So whenever the winds blow like this, moisture-laden winds, rather than moving perpendicular to the Western Ghats, they start moving northwards. This northward movement will actually give less rainfall on the Western Ghats. Two important things UPSC may ask you, right? When do you see breaks in the monsoon? North India breaks is associated when rain-bearing storms doesn't move over ITCZ. Especially Western Ghats, we see breaks mainly because winds blow parallel. This is very, very important for us. Once we read this, it's easy for us to understand the rhythm. Here, before I end, I just want to tell you about understanding the monsoon. We have seen with respect to El Nino, see guys, attempts have been made to collect data in the Indian Ocean where warm water is accumulating and where it is not. For this, we try to observe the difference in pressure between Tahiti in French Polynesia in East Pacific and Port Darwin, Northern Australia. I told you above Australia, usually low pressure should be there and high pressure should be there near Peru. So this difference between Tahiti and Port Darwin is usually recognized. My request to you, you have to remember these two places, because whenever you have low pressure over Darwin and high pressure over Tahiti, normally, if you have high pressure over Darwin and low pressure over Tahiti, then you usually observe El Nino. In newspaper, you will read that warm waters is accumulating near Tahiti, and this shows that India will be having less rainfall now. I hope you have understood monsoons now. If there is any queries, just let me know. I'll try to explain you in detail again, right? So I hope it's clear. If you are clear with this, let us go into the seasons which we have already seen and try to understand in different parts how rainfall is occurring again. So guys, let's quickly begin with the rhythms or the seasons. So let us look at the rhythm of seasons. We have cold weather, hot weather, southwest, retreating. So all these 4 seasons has to be seen in detail. We have already seen, I'll just explain you some of the points which are additional here. The first important thing is the cold weather season, which usually starts first in North India, then you will see it in peninsular India. Sometimes it goes to the extent that in peninsular India there is nothing called as winter at all when it comes to the coastal region because of the impact of sea in this region. So mid-November in northern India, December and January is the coldest months in the northern plains. The mean daily temperature remains below 21 degrees Celsius over most parts of North India. The night temperature will be quite low and sometimes it may be less than 0 degrees Celsius as well. In Punjab and Rajasthan, usually it goes to the freezing point. You have seen the northwestern part of India will receive highest temperature, and the northwest also receives the lowest temperature when compared to other parts of the country. There are 3 main reasons for the excessive cold in North India during this season. One is states like Punjab, Haryana, Rajasthan being far away from the sea will experience continental climate. I have told you if you are closer to the sea, you will usually observe sea breeze and land breeze which moderates temperature, but whenever I am talking about this, then usually it is different. The snowfall in the nearby Himalaya ranges creates cold wave situation. Snowfall means extreme low temperature means high pressure, winds blow from mountains onto land and this makes the entire climate to be cool. Around Feb, the cold winds coming from Caspian Sea, that is westerlies, usually blow over Caspian Sea and Turkmenistan and bring cold wave along with frost and fog over northwestern parts of India. Westerlies cover most of this region and they usually bring cold wave from the Central Asia towards India. The peninsular region of India, however, does not have well-defined cold weather season. If UPSC gives you explain cold weather season in India, first you have to talk about temperature and how exactly it varies in North India, temperature and how exactly it varies in peninsular India. Second important thing you need to talk is with respect to winds. There is hardly any seasonal change in the distribution pattern of the temperature in the coastal areas because of the moderating influence of this. I have already told you. Then we have to look at the pressure and winds. By the end of December, the sun shines vertically over the Tropic of Capricorn in the southern hemisphere. Because of this, high pressure will be there over North India. In South India, the air pressure is slightly lower. That is, the isobars of 1019 MB and 1013 MB pass through northwest India and far south respectively. As a result, wind starts blowing from northwestern high pressure zone to low air pressure zone over Indian Ocean in the south. That is, wind is blowing from land to sea. During this, some winds blow over Bay of Bengal and carry moisture and give rainfall to the southern part of Andhra Pradesh and Tamil Nadu. Right? This is what you need to understand. Due to low pressure gradient, the light winds with a low velocity of about 3 to 5 km/h begin to flow. By and large, the topography of region influences the wind direction and they are usually westerly or northwesterly down the Ganga plain, because the Ganga plain is also like this. When it is moving on the Ganga plain, it will be seen as westerly or northwesterly and become northerly in the Ganga Brahmaputra delta because it goes and hits the Arunachal Pradesh region and all, and wherever it is not there, they become northeasterly. Correct? And during the winters, the weather in India is pleasant. The pleasant weather conditions, however, has intervals which may be disturbed by shallow cyclonic depressions which are originating in Mediterranean Sea is brought to India via West Asia, Iran, Afghanistan, Pakistan, and it gives rainfall in northwestern parts of India. Some sort of snowfall is also observed in Himalayas. On their way, the moisture content gets augmented from the Caspian Sea in the north and the Persian Gulf in the south. What is the role of westerly jet stream? That is, westerly jet stream, whenever it is coming, it tries to bring these depressions towards India. Winter monsoons in India do not cause rainfall because they are moving from land to sea. I have repeated at least 100 times that in winter, winds are blowing from land to sea. It is because firstly, they have little humidity, and secondly, due to anticyclonic circulation on the land, that is high pressure, so there won't be enough rainfall. So most parts of India do not have rainfall, but there are certain regions which receive rainfall. Which are they? In the northwestern India, some weak temperate cyclones from the Mediterranean region comes, and westerlies and the jet stream brings them, and they are very less but still give rainfall for the rabi crops, and the precipitation is in the form of snowfall in the lower Himalayas. It is this snow that sustains the flow of water in summer, usually in the Ganges rivers. This is what you need to understand. We say that the Himalayan rivers are perennial mainly because of this. The precipitation goes on decreasing from west to east in the plains and from north to south in the mountains. The average winter rainfall in Delhi is around 53 millimeter. In Bihar, it may reduce to 25 and 18. Very, very important for us. Central parts of India also receives rainfall occasionally, not very much. Arunachal Pradesh, Assam and northeast India also receives rainfall during this particular period, and Tamil Nadu coast, southern Andhra Pradesh, southeast Karnataka and southeast Kerala also receives rainfall. Orographic rainfall is usually seen during this particular period. So winter rainfall is seen in most parts of India, but it will be very less. So rabi crop is also grown across. Because of climate change and other factors, today we are not seeing enough rainfall for rabi crops. Then let us take the hot weather season. With the apparent northward movement of the sun towards the Tropic of Cancer in March, that is at equator, March 21st, it will usually fall. April, May and June are the months of summer in North India. In most parts of India, temperature reaches 30 to 32 degrees Celsius. In March, the highest temperature is about 38 degrees Celsius. It occurs in the Deccan Plateau, while in April, temperature ranging between 38 to 43 degrees Celsius are found in Gujarat and Madhya Pradesh. In May, the heat belt moves further north, and in the northwestern part of India, temperatures around 48 degrees Celsius are not uncommon. Very, very important for us to look at this. That is, this just talking about the temperature. I have always told you, talk about temperature differences in different parts of India. The hot weather season in South India is not intense, similar to the winter as well, because of the breeze that takes place, right? This is very, very important for us. Some of the isotherms are parallel to the coast, confirms the temperature does not decrease from north to south, rather it increases from the coast to the interior. If you take the Indian coast, temperature will be less here, but once you go deep inside, it will be high. So high temperature inside and low temperature here. But when we actually look at the northern plains, it will be more near the northern plains, and once you come down, it will be less, right? This is very, very important for us. And then we need to understand pressure and winds. When I am talking about pressure and winds, the summer months are a period of excessive heat and falling air pressure in the northern half of the country. Because of the heating of the subcontinent, the ITCZ moves northward, occupying a position centered around 25 degrees north. Roughly, this elongated low pressure monsoon trough extends over the Thar desert in the northwest to Patna and Chotanagpur plateau in the east-southeast region. So you will have low pressure being developed first. Once low pressure is developed, southwesterly winds on the west coast as well as along the coast of West Bengal and Bangladesh usually give rainfall. Correct? This is what you try to see. So, they are easterly or southeasterly over North Bengal and Bihar. It has been discussed earlier that these currents of southwesterly monsoons are in reality displaced equatorial westerlies. The influx of these winds by mid-June brings about change in the rainy weather. See, what they are trying to say is, in ITCZ, we usually observe the winds blowing like this because of the rotation of the earth. Similarly, when we are actually looking, when ITCZ shifts northward, winds blow in this direction right in the northern hemisphere and they give heavy rainfall. This is what they want to talk here about, the displaced equatorial westerlies. Right? No need to worry much. What is more important is, in the heart of the ITCZ in the northwest, the dry and hot winds, often known as Lu, is usually observed. These are dusty storm and they bring different weather patterns wherever it blows. Dust storms in the evening are very common in Punjab, Haryana, Rajasthan and Uttar Pradesh. These temporary storms bring a welcome respite from the oppressing heat, since they bring some rain along with them. Whenever they blow, they give little bit of drizzle and they give some relief in the extreme hot climatic conditions of Delhi. Right? As you have extreme hot climate, you will find low pressure. Low pressure means winds are rising, and as they rise quickly, usually convectional clouds or convectional rainfall is observed. Then let us take mango shower. See, this rainfall, whenever the ITCZ shifts over different parts of India, wherever they shift, they give you heavy rainfall. So let me just give you an example. When sun is rising above, ITCZ will be here. So rainfall will be here. When sun shifts here, rainfall will be here. Again, rainfall will be here. Can you see, wherever ITCZ shifts, the rainfall also increases. So this is what we say, pre-monsoon showers. It is called as mango showers in Karnataka and Kerala, which actually helps in ripening of mangoes. It is also called as blossom showers, especially it helps coffee blossoms in Karnataka and Kerala. It is called as nor'westers or thunderstorms, Kal Baisakhi, in Bengal and Assam. And this helps in growing rice or cultivation in jute and rice cultivation in Assam and Bengal. And you have Lu, hot, dry and oppressing winds blowing in northern plains of India. All this is very, very important for us. Next, you are all aware about the southwest monsoon season. As a result of rapid increase of temperature in May over northwestern plains, the low pressure conditions over there gets intensified. We have seen again and again. By early June, they are powerful enough to attract the winds from the Indian Ocean. After crossing equator, they actually become southwesterly. I have at least repeated some 20 times. The rain in the southwest monsoon season begins rather abruptly, because as soon as the jet streams are replaced, easterly jet stream brings enough rainfall, and I have already told you this is called as burst of monsoon. We have already seen a lot about the southwest monsoon season. That is, we know that the winds blow southeast below equator. After crossing, it becomes southwest and enters into India. And it is divided into Bay of Bengal branch and Arabian Sea branch. Passing over the equatorial warm currents, after crossing the equator, they follow a southwesterly direction and is known as the southwest monsoons. The rain in the southwest monsoon season begins rather abruptly. This is what we have seen as burst in the monsoon, and sometimes there will be break, which we also have seen with respect to breaks in the monsoon, right? And here they try to explain in detail about the Arabian Sea branch and the Bay of Bengal branch. Before that, let me first explain you what exactly they want to talk here. You know that there is Western Ghats here. Winds, they usually come and hit the Western Ghats. And whenever they hit the Western Ghats, they usually give rainfall on the western side of Western Ghats, because as the clouds rise, they give rainfall. But on the eastern side of Western Ghats, rainfall usually decreases. This is one thing, that is, on the western side more rainfall occurs, and on the eastern side very little rainfall usually occurs. In between Kerala and Tamil Nadu, there is a pass called as, or gap called as, Palagat Gap. You can see in your atlas. So because of this gap, some rainfall actually enters into Tamil Nadu and gives some rainfall. And then when we are actually talking about the central India, you have Vindhyas and Satpuras, through which certain winds blow, and they give heavy rainfall in this region. And there will be another branch coming from Bay of Bengal like this, and these both will merge and they give heavy rainfall. Further, if I move above, we have Aravalli mountain ranges, which is also like this. But what happens? The winds after hitting Western Ghats, they start moving in parallel direction. So when they move like this, this particular portion will get rainfall. But here it is moving parallel to Aravallis, and here it is moving parallel to Aravallis. Because of this, they won't give any rainfall here. They usually give rainfall, or they move parallel, and this region doesn't give rainfall, and here they usually meet the Bay of Bengal branch. This is one important thing. Then when I take the Bay of Bengal branch, I usually observe that you have Himalayas and eastern branch. So it hits, turns back, and it starts moving towards Delhi. One branch will meet near the central India, another branch will meet near Delhi. The second important thing that you need to understand here is, when it hits, one portion may actually enter into Meghalaya. In Meghalaya, the mountains are like this. Clouds hit this, hit this, hit this. So usually they keep on hitting, again it hits, there will be some sort of funneling effect taking place. Because of this, there will be heavy rainfall present in the Meghalaya region. The other branch will usually move upward, and they usually give rainfall in the Punjab, Haryana a little. Can you see? First, the Bay of Bengal branch hits the east coast, and then it is moving towards northwestern part. Whereas when we talk about the peninsula, first it hits the Western Ghats and then it moves this side. So west will receive more rainfall, east will receive less rainfall. So guys, let me actually read out what they have given. So here we are talking about the Arabian Sea branch, which further splits into three. One branch is obstructed by the Western Ghats. These winds climb slopes of the Western Ghats, which is 900 to 1200, and whenever they climb, they become cool. As a result, windward side usually gives you heavy rainfall between 250 to 400. After crossing the Western Ghats, these winds descend and get heated up. This reduces humidity in the winds. As a result, winds cause little rainfall on the east of Western Ghats. So Kozhikode, Mangalore, Pune and Bangalore get different rainfall, mainly because one is on the western side, another one is on the eastern side of the Western Ghats. Another branch of Arabian Sea monsoon strikes the coast north of Mumbai, and they enter into Narmada and Tapi river valleys, and they give heavy rainfall in central India. Chotanagpur plateau gets rainfall. After this, they actually try to merge with the Bay of Bengal branch. This is very, very important for us. And then the third branch of the monsoon wind strikes the Saurashtra peninsula, and here they move along western Rajasthan and Aravallis. As they move parallel, they usually give less rainfall. In Punjab and Haryana, it too joins the Bay of Bengal branch. These two branches, reinforced by each other, cause rains in the western Himalayas. Very, very important for us. Next important thing is Bay of Bengal branch. The Bay of Bengal branch strikes the coast of Myanmar and Bangladesh, but the Arakan hills along the eastern Himalayas usually deflect big portion of the branch towards Indian subcontinent. The monsoon therefore enters West Bengal and Bangladesh from south and southeast direction instead of from southwesterly direction. From here, this branch splits into two under the influence of Himalayas and the northwest India. Its one branch moves westward along the Ganga plains reaching Punjab plains. The other one will be moving over the Brahmaputra valley in the north and northeast, causing widespread rains. Its sub-branch strikes the Garo and Khasi hills of Meghalaya. Mausim Ram, located at the crest of Khasi hills. Usually UPSC asks you, Mausim Ram is present just below which of the following mountains? Receives the highest average annual rainfall in the world. Tamil Nadu doesn't receive rainfall from the Bay of Bengal because Bay of Bengal branch moves parallel, and also Arabian Sea branch doesn't give rainfall because Tamil Nadu is present on the leeward side. Only near Palakkad Gap it receives rainfall. So this is very, very important for us. Then we need to read about the characteristics of rainfall, which says that the rainfall usually occurs between June and September. Monsoonal rainfall is largely governed by relief and topography. That is, if you have western Ghats like this and winds are blowing like this, they give you rainfall. But winds, if they move parallelly, then they don't give you rainfall. Right? Windward side of the western Ghats receive, eastern Himalayas receive. All this is very, very important for us. The monsoon rainfall has a declining trend with increasing distance from the sea. For example, Kolkata receives 119, whereas Patna receives 105, Allahabad 76 and Delhi 56. UPSC may give you to arrange this in an order. The monsoon rains occur in wet spells of few days duration at a time. The wet spells are interspersed with rainless interval known as breaks. These breaks in rainfall are related to the cyclonic depressions mainly formed at the head of the Bay of Bengal and their crossing into the mainland. Besides the frequency and intensity of these depressions, the passage followed by them determines the spatial distribution of rainfall. I have already told you about the breaks and what causes the breaks. The summer rainfall comes in a heavy downpour, leading to a considerable run-off and soil erosion. Very, very important for us. Monsoons play a pivotal role in the agrarian economy because 3/4 of our total rain is usually received during southwest monsoons. Its spatial distribution is also uneven. In few regions it gives only 12 centimeter, but it gives 250 centimeter in different parts. Because of this, different rainfall is observed in different regions. The beginning of the rain sometimes is considerably delayed over whole part of the country or only a part of the country. The rains sometimes end considerably earlier than usual, causing great damage to the standing crops, and the sowing season of the winter crops also become difficult. Any changes will have huge impact. Season of retreating monsoon. With the southward movement of the sun, we also see that the monsoon winds will retreat. The months of October and November are known as the retreating monsoons. By the end of September, the southwest monsoon becomes weak as the low pressure trough of the Ganga plain starts moving southward with the response of the southward movement of the sun. The monsoon retreats from the western Rajasthan by the first week of September, and the winter starts there immediately after that. By the beginning of October, the low pressure covers northern parts of Bay of Bengal, and by early November, it moves over Karnataka and Tamil Nadu. Right? Once it enters into Indian Ocean, especially Bay of Bengal, they give you heavy rainfall. Usually, this retreat is observed with some sort of heat commonly called as October heat. Very, very important for us. And then we need to understand widespread rain in this season is associated with the passage of the cyclonic depressions which originate over the Andaman Sea, and it is brought from Andaman Sea towards India through the northeast trade winds which usually blow. The thickly populated deltas of Godavari, Krishna will be usually affected, as this brings heavy downpour and may affect the entire coast, right? A bulk of the rainfall of the Coromandel coast is actually derived from these depressions. Tamil Nadu usually get rainfall because if you take the depression when it is moving from Bay of Bengal over Tamil Nadu, they are moving from sea to land and they give heavy rainfall. And then they talk about the traditional seasons on the basis of rainfall. So this is required from prelims point of view. Try to see that distribution of rainfall is very, very important. Guys, you are all aware areas of high rainfall. First, along the west coast, especially on the western side of Western Ghats. Second, sub-Himalayan areas, especially in northeast India. In some parts of Khasi, Jaintia hills, they give you heavy rainfall. Brahmaputra valley also gives rainfall. And then when we talk about areas of medium rainfall, we talk about the southern parts of Gujarat, east coast of Tamil Nadu, which receives rainfall from both southwest monsoons and also cyclonic depressions, northeastern peninsula covering Odisha, Jharkhand, Bihar, Madhya Pradesh, central India through Narmada valley, areas of low rainfall usually western UP, Delhi, Haryana, Punjab, Jammu and Kashmir, Gujarat, Rajasthan, all this. Inadequate rainfall usually the leeward side of the mountains, right? This is very, very important. On the basis of this, there are different climatic classifications and NCERT books talks about the Koyappan classification. Here you should understand certain basic factors. This will help us in understanding the global climate as well. First important thing is tropical climates. What is the meaning of tropical climates? Even in winter, temperature will not be less than 18 degrees Celsius. That is, the temperature will be more than 18 degrees Celsius throughout the year. Second important thing he says is with respect to dry climates. That is, if it is completely dry, he calls it arid. If it is less dry, that is if rainfall is there in some point of time, we call it semi-arid. So he gives capital S for semi-arid, W for arid regions. Warm temperate region, 30 to 45 degrees Celsius is called as warm temperate region, where the temperature will be between 18 degrees Celsius and minus 3 degrees Celsius. Whereas cool temperate, temperature will be warmest month is over 10 degrees Celsius and the mean temperature of the coldest month is under minus 3 degrees Celsius. See guys, if it is 18 degree throughout, above 18 degree throughout, you call it tropical, correct? And if I am actually talking about 18 degree to minus 3 degrees Celsius, warm temperate, maximum is 10 degree and minimum is always less than minus 3 degree, we call it cold temperate. If frost is usually seen, that is under minus 10 degrees Celsius, we call it cold deserts. With increasing height in India, we find different climatic regions. Koyappan also uses different letters. For example, he used S for semi-arid, W for arid, F means sufficient precipitation, M means rain forest despite a dry monsoon season, that is evergreen forest is there even when you find some sort of dryness. W, dry season in winter. H, dry and hot. C means less than 4 months with temperature over 10 degrees Celsius, that is we are talking about cold temperate region. G means Gangetic plain. On the basis of this, he tries to divide Indian climate into this. Can you see AMW? A means tropical, M means monsoon, and there will be short dry season. AS, monsoon with dry summer. There will be monsoon, but there will be dry summer, right? AW, leeward side where grasslands are usually present. BW, HW, semi-arid, steppy type of climate, that is we are talking about grasslands but they are a bit cool. And then we have BW, this is BWHS, you have to change it. S stands for semi-arid, BWHW is hot desert. Then you have CWG, that is monsoon with dry winter. Monsoon takes place, but you have dry winter as well. I'll show you the places properly. First, let's see one after the other. AMW, west coast of India, south of Goa. Monsoon with dry summer. Usually monsoon is available in summer, but Tamil Nadu coast receives winter rainfall. So monsoon climate with dry summer. Tropical savanna, most of the peninsular plateaus south of the Tropic of Cancer, especially on the eastward side of the mountains. BWHS, northwestern Gujarat, some parts of western Rajasthan and Punjab. Hot desert, extreme western Rajasthan, where there won't be any rainfall at all. Monsoon with dry winter. Ganga plain, when does it receive rainfall? And G, you know, stands for Gangetic plain, right? Ganga plain, eastern Rajasthan, northern Madhya Pradesh, most of northeast India. That is, you will receive monsoon rainfall, but you will also see dry winter throughout. DFC, cold humid winter with short summer. Arunachal Pradesh, where mountainous region is present. Polar, Jammu and Kashmir, Himachal Pradesh and Uttarakhand. Can you just observe this? Polar is present in this region, correct? Mountainous region with some time where sunshine is available is Arunachal Pradesh. And then can you see here, steppe type of climate, hot deserts are present. Central India, monsoon will give rainfall, but winter will be usually dry. Can you see the other parts, savanna type of climate? And then can you observe monsoon with short dry season? And can you see steppe type of climate on the leeward side, that is rainfall will happen but grasslands will be there, increasing height. And then can you see monsoon with dry summer in Tamil Nadu, right? So what all we see? AMW. The meaning of this is monsoon with short period of dry season. Then we have semi-arid region or monsoon with dry summer. Then we have AW, which means savanna type of climate. Then we have BSHW, steppe type of climate on the leeward side of Western Ghats and also closer to Rajasthan. Then you have BWHW, we are talking about hot deserts. Then Gangetic plain is there, CWG comes in. Then you talk about DFC, precipitation is there, but maximum you see 10 degrees Celsius only for 4 months, Arunachal Pradesh. And then you have polar region E, right? AMW, AS, AW, BSHW, BWHW, CWG, DFC and E. Very, very important. High possibility UPSC may give you this particular map and help you to match them accordingly. Last guys, monsoons and economic life of India, go through it once, nothing much to see and it's not important as well, right? But in exam, whenever they ask you these questions, it will help you to write. So I have explained here how different rainfall is usually seen. Next we will be taking up how exactly we are going to see different vegetation in the world. So in this chapter, even though we took time, we tried to understand different seasons and high possibility questions can come, and students usually get confused in this particular chapter. So please go through this carefully again so that you don't miss any point. Later we will quickly start with next chapters which are factual in nature, but we can try to analyze on the basis of what we have seen in this particular